Okay, so let's look at the paddle. So the paddle implements two interfaces, Sprite and Key Listener. Sprite, Sprite because it's a game object and it's got to be displayed on the screen. Um, Key Listener because it's got to listen for keyboard input. It's got X and Y values for its location. It's got W and H for its width and height, and it's got a velocity in the X direction. I've got two booleans, left pressed and right pressed. If the left arrow button is pressed down, left pressed will be true. As soon as that left arrow button is released, left pressed becomes false, or will become false. I'll have to write the code to do that, but I've created those variables to store that information. And the paddle has a color. So in the constructor, it initializes the color, and this value 0x 8bc7d9, I got that. That's hexadecimal. I got that from a website called Color Picker. So if I just go to Google, I type in Color Picker, the first website, www.colorpicker.com. This is a useful website, and you can choose any color you like. And I find that, when I'm doing stuff, I often like to create things that are sort of in this pastel area. Up here where it has the pound symbol and it says BBE691, that's a hexadecimal number that describes this color. The BB tells you how much red, the E6 tells you how much green, the 91 tells you how much blue. So BB is really, if you convert it to a base 10 number, is 187. E6, if you convert it to a base 10, is 230. And 91 in hex is the same thing as 145 in base 10. But I like to just copy paste, select this, do a Control C, and then into Eclipse I would do a Control V, and then add a 0x. In Java, if you want to identify a number in hexadecimal format instead of base 10, you just prefix a 0x on it, and then Java will understand that the rest of it is a number in hexadecimal representation. Okay, and so we can represent a color in hex values. So we create a new color for the paddle. We give it a width, that'll be 80 pixels, a height of 20 pixels. We give it an x coordinate, game width over 2 minus width divided by 2. So the x value is going to be the left edge of the paddle. And so if I want to put the paddle in the middle of the screen, width over 2 gives us the middle of the screen, minus the width of the paddle divided by 2 gives us the left edge of the paddle, because we want the middle of the paddle to be in the middle of the screen. And then y is equal to the game height minus the height of the paddles, because y is going to be the top edge of the paddle. So we want the top edge of the paddle to be just high enough so that the bottom edge of the paddle is at the bottom edge of the screen. So the paddle had to implement update and draw and is dead because it implements the sprite interface. So when we update a paddle, we adjust its x position based on its x velocity. I've multiplied the x velocity by a number just slightly less than 1. I like to think of that as friction. That's what slows the paddle down. If you take your finger off the button when you're playing the game, the paddle gradually slows to a stop. Now, if you want it to increase the friction, you make this number closer to 0. So after you change the position based on the velocity, you decrease the velocity a little bit. If x is less than 0 and the velocity is negative, since x is the left edge of the paddle and 0 is the left edge of the screen, another way to say this is if the left paddle is to the left of the screen. So if it's gone off the left edge of the screen and the velocity is negative, means it's still going further to the left, then Vx multiply equals -1. So what this will do is if it's got a negative velocity and it's off the left edge, make its velocity positive. This is why the paddle bounces off of the left edge of the screen. And likewise, if x plus the width, if the right edge of the paddle is bigger than the width of the screen, so if the right edge of the paddle has gone off the right edge of the screen and the velocity is positive, then multiply that velocity by -1. Make it negative so that it bounces off the right edge of the screen. If the left pressed, so if the left mouse button, or I'm sorry, the left arrow on the keyboard is pressed, then subtract a little bit from the velocity, decrease the velocity. So this is like pushing it to the left. And the longer you hold that button down, the faster it'll go to the left. And if right is pressed, increase the x velocity by a little bit. And so that's what pushes it to the right. When we draw it, we just set the color and then draw a rectangle in the appropriate spot, x, y, with the appropriate width and height. Now you notice that fill-rect method of a graphics object expects integers, and we've stored everything as doubles. Now I have found through experience that if I've got some value, like a velocity and a position, if I start out storing this as integer values, what'll happen is if it's moving very, very slowly, if the velocity is less than 1, it'll make the velocity 0. And so if I store it as an int, it limits how slow my paddle can move. It will move at slowest 1 pixel per update. I get better motion, better results by storing things as doubles. As a general rule, I like to store things as doubles as long as I can. There are some things that just make sense to store as integers. But if there's a choice, I'll store it as a double. I generally prefer to store things as a double. And then if I have to convert it to an int, I wait as long as I possibly can and do the conversion last. And so I do the conversion as I draw it on the screen, which is the last possible moment. So what's drawn on the screen is integer values, but what's stored inside of the paddle is double. Is dead is false, so the paddle never dies. Now, the key typed, key pressed, key released, those methods were all required by the key listener interface. We don't do anything with key typed. We don't need anything there. Key pressed. So when a key is pressed on the keyboard, the key pressed event occurs. I'm sorry, the key pressed method gets called. The paddle receives a key event which stores some information about which key was pressed. So you can get the key code from that key event and check to see what it's equal to. Key event has certain static fields. Okay, so if you type in key event dot, you'll get a list of a bunch of stuff. And all the stuff that it starts out with VK underscore, that stands for virtual key. Those are values that represent various keys on the keyboard. VK underscore left is for the left arrow button. VK underscore right is for the right arrow button. So if I say key event dot VK underscore. 0 is for the 0 key, 1 is for the 1 key, and so on, all the way up through 9. You've got all the letters A through Z. There's the Alt key. There's few things. There's ampersands, asterisks. So you've got various things for all the different punctuation marks. Backslash, left brace, right brace. You get the idea. There's something for the escape key. So you can find something for any of the keys on the keyboard and various key combinations as well. So if the key code is equal to VK underscore left, then this event occurred because they pressed down the left arrow key, so make left pressed true. If the key code is equal to VK underscore right, then make right pressed true. The key released event occurs when they take their finger off of a key. So if the key code is left, it means they took their finger off of the left arrow button, so make left pressed false. If the key code is VK underscore right, then make right pressed false. Now you might wonder, why don't we just use key pressed and increase the velocity when they press the key? Well, here's the thing. These key events were designed not for games, but they were designed for programs like word processors. And so when this event gets called, when they first press the key down, and then if they hold it, after a little while, it starts to repeat very, very quickly. What you don't want is when you first press the key for your paddle to move a little, and then after a little while for it to suddenly start to move really, really fast. What you would rather is to have an immediate reaction and for it to repeat at regular intervals. So the one thing that we've got that already repeats at regular intervals is an update method. This is called by the game every 20 milliseconds. So the moment they press the key down, the variable up here becomes true, and it stays true until they let their finger off. And so every time we update, if it's true, we just adjust the velocity appropriately, and if it's false, we don't. And so it reacts immediately when they press the key down, and it continues to react until they pick their finger off the key. So this get mid and get y, these are methods we've added to the paddle. This will return the middle of the paddle, so it's x plus the width over 2. Get y returns the location of the top edge of the paddle. And these are used by the puck when the puck has to bounce off of the paddle. It's got to figure out where the paddle is. And so we've added these methods as helper methods to help the puck calculate the appropriate bounce. Do hit. Do hit we had to implement because it implements the sprite interface, and this will be called by the game. So the do hit method of a paddle receives a puck. The puck has some helper methods, get x and get y, and get r. So this gets the center of the puck, x and y, and the radius of the puck. And then we've got to figure out whether or not we hit the puck. So we get the puck's x, y, and its radius. And if the puck's x value is less than x minus the puck's radius, okay? So x is the left edge of our paddle. We subtract the radius because we don't want to know if the center of the puck is hit, but if the center plus the radius. So I guess I could rewrite this to make a little bit more sense. Px is the center plus Pr is the right edge of the puck. If the right edge of the puck is less than the left edge of the paddle, so this would mean it's too far left. It's not a hit. If the puck's x, I'm going to say minus the puck's radius, that's the left edge of the puck. If the left edge of the puck is greater than the right edge of the paddle, then the puck is too far to the right. It didn't hit the paddle. If Py, I'm going to say plus PR, if the bottom edge of the puck is less than Py, is above the top edge of the paddle, then again, it's not a hit. Or if it's below the paddle, is not a hit. So if the puck is too far up, down, left, or right, just go ahead and return. Don't do anything. The puck didn't hit the paddle. If you get down here and didn't quit, that means the puck hit the paddle. Just tell the puck to bounce off of the paddle. Okay, so the paddle passes itself to the puck, and then the puck is going to bounce appropriately. We'll see that when we get to the puck. Okay, so that's how the do hit works. So do hit for a paddle just checks. It gets the position of the puck, and it checks to see if the puck is too far left, right, up, or down to hit. And if it does, it just quits. Otherwise, it tells the puck to bounce off the paddle. So that is the paddle class. See the next class in the next video.